Everybody, it's Mrs. Francis. Hope that you guys are having a great day. This is just a quick little video to give you some help with the instructions and some tips for Molecule Lab B. So let's get right to it. I want to just kind of start at the top here. First of all, you're going to need to use your notes from last class on molecular shapes. You're going to be doing some naming here. With this naming, I recommend that you do all of the naming at once while it's fresh in your head. And I just go down the columns. So if I turn the page here, I would just name all the way down and then do the name all the way down. I think that's going to be helpful. You're going to need to do the have, want, need bond, as Miss Olson and I both went over for you. There is a very special note here for polyatomic ions. You're going to run into one of these at the end for nitrate, NO3-1. Hopefully you have that memorized, the name. And then for drawing the compound, one of the important steps is circling the central atom. And I would recommend, again, that you do all of these in the column. So like this here, where we've got the CO2, you would circle the C and CO2, then you do it for the next one, the next one, the next one, all the way down. Keep in mind, hydrogen and halogen can only form one bond, and your halogens are group 17, fluorine, chlorine, bromine, iodine, etc. And then you might want to make yourself a little chart here. The more you practice this, the easier it gets. So tetrahedral has 4 different attachments. Bond angle 109.5. Trigonal pyramidal, we have 3 attachments, and it looks as if we've just removed the top. Instead of being a bond, there is a lone pair here. That causes the legs to come closer together. So our degrees or our angle gets smaller, 106.5. Bent 2, we take out that back leg, and so we've got 2 connections here, 104.5. There's 2 lone pairs up here. That's where we split our chart on our notes. We start with a new structure. We've got here 3 attachments or 3 areas of bonding. 1 is a double bond. This is sort of our piece shape, 120 degrees. Next, we've got our bent, where we remove one of those single bond legs. We keep a double bond, 1 single bond, and then there's a lone pair here to satisfy the octet. And we're down to 118 degrees as that lone pair pushes the legs together. Finally, we have linear. With linear, we would have 2 double bonds, no lone pairs on the central atom. And we also have this variation where we've got a triple bond and then a single here. I did put a little reminder that there's really no shape when you have 2 atoms being connected here. So this is an example of when we've got 2 atoms and really no shape. You might hear some people say linear, but it's just really sort of. All right. Next, I wanted to note to you on this page here that when you get to C2H4, this is one of our organics. You'll give it its traditional or its name, dicarbon, etc. But I want you to know that its name that it goes by typically is ethene. And when you have an ethene, it means that you have a double bond between the carbons. Obviously, a hydrogen cannot have a double bond because it can only have 1 bond. So there is going to be a double bond that's really going to give you a help when you go to do the Lewis structure, and you'll end up, because there are 2 carbons with 2 shapes. Okay, on the next page, I wanted to point out the same thing for C2H2, so you've got 2 less hydrogens here. The name is ethyne, and as I had indicated in the previous notes, that ethyne, when it ends in YNE, means that there is a triple bond. Okay, now finally, I want to go to nitrate. I said that there was a special note And the note was regarding this extra electron. So this electron actually gets added into the have only. So basically we're saying that this ionic compound or ionic structure will form an ionic compound, but the nitrogen and the oxygens are covalently compounded together or bonded together. So our nitrogen has 5, oxygen has 7 times 3, so that's 21. So for our halves, we've got 5 plus 21 plus, oh, I did that wrong. It's 6 times 3. Sorry, that's 18. See, even I make mistakes here. So 6 times 3, 18. It didn't make sense to me. And so that's a total of 24. Our wants, 8, and 8 times 3 is 24. So that's a total of 32. And we get 8 electrons that need to be shared. And that will happen in 4 bonds. Now, there's only 3 attachments here, which means you're going to have a double bond somewhere. So keep in mind that you will end up with a double bond between one of those nitrogens and one of those oxygens. So hopefully that'll help you out. We will be having office hours, and make sure to come visit your teachers for office hours, or email us or send us a note. This you're going to definitely have to take some time to work through. It doesn't come automatically, but I promise you that if you really put a good effort into it, use your notes, you will eventually get there. So you can do this, and thanks so much. Have a great day, everybody.